satellites are burnt out. There are no phones, no television, no radio, no internet.
The whole infrastructure would be damaged. We wouldn't have communications. We wouldn't have so many different things.
And the electricity will not be coming back.
We could damage enough transformers in one storm that it would take several years of the entire world's manufacturing capability to replace all of those damaged transformers.
Without power, infrastructure collapses. The first thing to go, water. Without electricity for pumps, city tap water will go dry within a day. The same is true for gas pumps and gas stations. Without fuel, national trucking stops. So do food deliveries to grocery stores. People can't leave the cities because their gas tanks are empty. They can't use their credit cards or ATMs without electrical power and phone connections. No power, no gas, no food, no water, and no end in sight.
Think of totally destroying the power grid of an entire continent. We would be basically put back in the Dark Ages.
And no help is coming, since the magnetic storm has devastated the entire northern hemisphere.
These storms have a planetary footprint. They extend not only across the entire continents, but arguably across the entire planet.
It's not just a magnetic storm. It's a magnetic apocalypse.
There would be billions or even trillions of dollars of lost economy.
And that's not the only thing lost.
The consequences and the potential for loss of life are quite large. Perhaps taking out a third to a half of the population of the civilized portions of the world.
Sound unlikely? But that is exactly the conclusion of the National Academy of Sciences report from 2009. A magnetic storm from the sun could wipe out our technological infrastructure, killing millions of people and destroying much of what we think of as 21st century civilization. It's not just guesswork. A solar magnetic storm actually knocked out power to Quebec in 1989, blacking out an entire Canadian province. But that storm was small.
We're seeing storm events over the last 30 years or so that jumped up literally 10 times larger than that 1989 storm.
A new generation of solar satellites has revealed just how big these solar flares are and how vulnerable our planet is.
As society, we are not prepared for a long-term blackout of the power grid.
Can this scenario be prevented? Possibly, but only by understanding one of the most basic forces of the universe and one of the least understood, magnetism.
Magnetism is key to understanding a lot of physics because it affects a lot of things. It affects how stars condense. It affects how galaxies form. It affects how black holes collapse.
Magnetism is everywhere and in nearly everything. It is one of the four fundamental forces of physics, the forces that keep the universe itself together.
Physicists have identified four fundamental forces at play in nature. There's a strong nuclear force that holds atoms together, the weak nuclear force that also has to do with holding together particles and atoms, and gravity, with which we're all familiar, and then electromagnetism is the fourth. Electricity and magnetism are really one and the same thing.
For something so fundamental, magnetism often gets overlooked. Besides holding notes on your refrigerator, magnets rarely show up in an average person's daily life.
Magnetism is not something that we normally deal with. You can't feel a magnetic field. You can run a magnet over yourself and you don't feel a thing. So it isn't part of our daily experience.
The key component of magnetism, is that it attracts and repels.
I'm holding here two magnets to illustrate how magnetic fields work and, frankly, how strong they are. Right now, they're attracting one another, and I have to really pull to pull them apart. But they also can repel each other, and I can illustrate it by putting it on this post. If I put the first one down and drop the second one, I really can't push it down. It just bounces.
In fact, the only thing that keeps people from walking through walls or falling through the floor is magnetism. Molecules and atoms are extremely small, and the space between atoms is extremely large. At an atomic level, almost everything is made of empty space.
The distance between the electrons that are orbiting around the protons in the nucleus is fairly immense. It's like this fan. If you let the electrons be the blade and the center be the nucleus, if there's no motion taking place there, you would pass right through things. It's not solid. So why is it solid? It's because the electromagnetic attraction between the negatively charged electron and the positively charged proton, it captures it and it spins around. So if it's spinning really fast, like the fan blades of this fan, representing the electrons around the atom, it bounces right off. That's why you don't fall through the floor and why you can't walk through walls.
It's not the atoms themselves, but the magnetic field that makes matter solid, that keeps a person from walking through walls. Magnetic force attracts and repels along field lines.
You can take a bar magnet and lay a piece of paper over it and cover that piece of paper with iron filings. And the iron filings will actually line themselves up along the field lines coming out of the magnet. And that's a good way to see what the magnetic field actually looks like.
One way to think of field lines is like lanes on a freeway. The southbound traffic never interacts with the northbound traffic.
Electromagnetic field lines are like lanes on a freeway. Cars go down the lanes, down the freeway. And that's why if you look on the surface of the sun, you see these beautiful arcs that represent the field lines where the plasma can flow.
But on the surface of the sun, these field lines are intensely powerful and deadly. In this freeway analogy, imagine if a middle lane was opened up on the freeway between the speeding north and south traffic.
There's no instruction as to who's supposed to go on that lane. You'll get a big mashup right there where everyone's trying to go on that lane, and chaos ensues, and there's a big release of energy.
Now imagine if this freeway was on the sun and the cars were 20,000 miles long. The enormous crash fires material off the sun and straight toward our planet. That is a coronal mass ejection. A CME is gigantic, over 10 billion tons of solar plasma. It's the equivalent of 100,000 aircraft carriers traveling at several million miles per hour toward Earth. This is the threat to our planet. A direct hit from a CME is a rare occurrence, but it would be catastrophic for our civilization.
We're literally one big storm away from an engineering disaster.
The sheer size of that disaster has only become clear with new reports from the cutting edge of solar science. Disturbing new information from satellites might help us predict the next deadly blast of a magnetic superstorm. Magnetic solar storms have only recently been shown to be a deadly threat to the Earth. The sun is constantly ejecting material, from radiation to X-rays to solar flares to coronal mass ejections. The reason these ejections don't routinely hit us is that Earth is protected.
The Earth has this huge magnetic field surrounding it. It's all around the thing. And what happens is, if there's a solar flare, a coronal mass ejection, our magnetic field is our savior. It's our armor.
Imagine the Earth as this globe, and the sun is a shotgun. The sun fires off powerful blasts toward the Earth every few days. But the planet has a protective shield, like a sheet of plexiglass that protects a globe from shotgun blasts. It's called the magnetosphere, a gigantic magnetic field generated by the planet's churning core. It extends out 43,000 miles. Just as a ring magnet repels another ring, Earth's magnetosphere repels the magnetized plasma from the Sun. 1 billion tons of superheated, electrically charged plasma hits our planet, and normally just rolls around it.
The electromagnetic shield of the Earth is a shield. Charged particles try to get in, but they bounce against and get redirected by the magnetic field.
Only a tiny piece of the magnetic storm gets caught in the small opening at the planet's poles, where we see it as the Northern Lights.
Earth's magnetic field redirects energetic particles to the poles of the Earth. And we see that when we see the northern and southern lights. Those particles interact with the Earth's atmosphere and cause it to glow. And it's a beautiful light display.
The magnetosphere can redirect electromagnetic material, which allows life to flourish on Earth. Without it, radioactive particles would likely kill off all forms of life. Fortunately, the field directs away some material, like solar flares, and allows other materials into our planet's atmosphere, like light and heat.
You might wonder, how is it that our magnetosphere protects us from coronal mass ejections, but the sunlight still comes right through, and we have daylight? Well, that's because the coronal mass ejection is mostly charged.
I began to push even forward in time, over the horizon, the future. Can remote viewing, how effective is it against future events? I was looking ahead to see if we could put together an outline for our bosses of events over the horizon. We were particularly interested in military events, not necessarily civil, social and economic events, particularly military. Viewers began to pick up on a very large event that at first I thought was a nuclear war or something geophysically tragic that affected the globe. It took a lot of work, a lot of analysis to collect information about what this huge event was that affects the entire planet too. So we were getting closer to discerning what we were dealing with. We began looking closer at this. We began to sketch a spherical object that was very big. I thought, oh, maybe this is a comet. Certainly not a meteor, because it's on fire. And it's the thing that's going to affect this event that we're picking up in the future. So we did some more work on it. It wasn't a comet. It was big and on fire and right next door in our neck of the woods. It was our own star, the sun.
Specifically, viewers foresaw a series of solar flares that are so powerful they penetrated into Earth's atmosphere, destroying global communications and heating up regions of the world to such an extreme that it would cause the deaths of billions. Our star, man's source of life, would now become our greatest enemy.
Of course, we continued this work about how could we not? And we were concerned about exactly the nature of it. How survivable, if at all, was it? How many would survive and under what circumstances? Those kinds of things. And especially, how far out in the future were we looking at? Was this 500 years, 50 years, 5 years, 5 months?
The North Korean prediction appears capable of coming to pass any year now. But there is another event that remote viewers fear the most, a sign that the kill shot is imminent.
What would be that final recognizable event just prior to the kill shot sequence? The best that we could come up with, pushing ahead, the best that we could come up with was what appeared to be a space shuttle being forced down by what appears to be a meteor shower or something like that. For those of you who are not remote viewers, let me give you a little bit of insight into what remote viewing is in terms of a skill set. Most of the information that we derive from a target is in terms of word idea concepts, patterns of information that we perceive and turn into word, search our memory for words and apply those words, a written word on a piece of paper, and move on. The information we had that led us to believe that we're dealing with a space shuttle as a final precursor event to space shuttle coming down, as a final precursor event to the kill shot, was a collection of those rough sketches. So analytically, we're saying it looks like the space shuttle coming down.
As a result, there had been some confusion by not only the public, but also many remote viewers. The session sketches generated had resulted in the assumption that the craft being forced down was a U.S. space shuttle, since it was unique to the world at the time of the prediction.
Our sketches and drawings look like the current, very similar to the current U.S. space shuttle vehicles. There are some variations among viewers too, but we know that the Air Force has another program now, a nascent program. I think it's a spy vehicle that's up there, a maneuverable vehicle. That particular vehicle also looks like the U.S. space shuttle, the manned space shuttles.
Today, the recent U.S. space shuttle design is being emulated by many different space agencies around the globe, both government-oriented and private. No longer is the design unique to the U.S. space program, but the precursor itself remains the same. When a shuttle-like craft is forced down from orbit, the kill shot will begin.
When you see these particular events happen, that last one in particular, we don't know how much longer it will be until the kill shot, because mind is outside of time. The best that we could do is say this event is the last big one that you'll see as remote viewers before this kill shot sequence happens. Regardless of how long it is, that period between this shuttle event and the beginning of the kill shot sequence, we know as viewers, and I have personally viewed this particular event a number of times because it's so powerful, that all of these warring parties that we see on the planet, all these many wars, that on the ground, all of these soldiers look up in the sky. They all look up. So something is happening in the sky. In fact, there's probably unprecedented atmospheric effects that in a recorded history, perhaps an unrecorded history, there's been events like this, but nothing in recorded history. Something happens in the atmosphere that has not been seen before, because all these soldiers are looking up, and then they go home. Their priorities change. They go home. So that's when it starts. This kill shot sequence will cripple communications worldwide. It will take out satellite communications in a very short order. Power grids, we're all aware of what it will do to power grids and what it has done in the past, and in certain instances, go back and check it out. Power grids will go down. So many people over many months of time, and throughout the world, will have no power. There are cities without power and communication. You can figure out for yourself what that will mean too. Not only will you not be able to pump gas, not only will you not be able to pump water, not only will there not be food on the shelves because there'd be no gas in the trucks to take the food to the cities, but I could go on and on. There are some tangential effects that we're picking up also as remote viewers and have picked up over the years. Apparently, the center of the Earth, the core of the Earth, is changing rapidly as an effect of what is happening on the sun. And if that's the case, then we're probably looking at, as an adjunct to effect to the kill shot sequence, we're probably looking at massive volcanism and earthquakes as well. And I think it's very important to point out, and very important indeed, because of the adiabatic heating of the atmosphere, we're going to have very high winds in many parts of the Earth. The the sky, the sun, the light will be obscured. It will be very difficult to grow crops on a surface because of both winds and lighting conditions. Solar physicists were chewing their nails because they were very, very concerned that the sun had been very quiet for so long, and this was not predictable. And so because it was not predicted, it did not follow the solar cycle, they were afraid that the sun might be doing something erratic. And that's when we began to see in the press and the news all these warnings about what major solar flares would do to the planet, to communications, to power grids, etc. And then in the last few months,